can just offer the current product right away, right? However, if it wants to make quality improvement, then there are different levels of decision it has to make. The first level of decision to think about is what technology to choose. Well, option one is to go with a well-tested, mature technology with deterministic level of quality improvement. The second technology to go with is a innovative, risky technology which gives the firm uncertain levels of quality improvement. So that's the first level decision. The second level decision is, should the firm offer a high quality or low quality product, given it has already chosen this type of technology. But first thing first, how do we define the quality of a battery, right? In general, there are two main attributes that will affect the overall quality of a battery. The first attribute is called the capacity, which is the maximum amount of energy that could be extracted from the battery. So this is the decision variable by the firm, and usually controlled by the firm to influence the overall quality of the final product. The second attribute, the cycle life, which measures the number of charge and discharge cycles this battery could perform before this performance got formed. So this is an exogenous parameter and usually associated with a certain level of uncertainty, depending on what type of technology the firm is using. So all right, so now we are looking at the problem of new product design when the firm has an option to choose from an uncertain technology and a deterministic technology, and also this product has multiple quality attributes. So these sequence of events happen in a two-stage period. In the stage one, the firm makes the product design decisions by choosing which technology to offer, and also how does it design the corresponding quality level. Fixed costs is also incurred in stage one. Well, the stage two is called the pricing stage, where at the beginning of stage two, the uncertainty on product quality realizes, and then the firm makes corresponding pricing decisions. So this is a two-stage game, and we use the backward induction to start from stage two by solving the optimal prices, and then substituting the optimal prices back into our objective function and go back to stage one to solve for the product quality design problem. So here, the quality design problem happening before the pricing problem is because usually the quality design is a long-term strategic decision by the firm, whereas the pricing decisions are usually medium to short-term technical decisions. All right, any question? With this framework, we're trying to address the following questions. The first one is, given the firm has chosen the particular type of technology, what is the optimal level of improvement on battery capacity, which also determines the overall product quality. Second question is, what is the effect of uncertainty on the firm's product quality improvement and the optimal profit? And the final question will be, if we go even one step further, how does the firm choose between these technologies in the very beginning? So we position our work in the intersection of two literature streams. The first literature looks at the problem of quality design. Specifically, how does a firm offer a family of quality differentiated products to the market? And then whether the firm should do it sequentially or simultaneously. In some of the papers, the authors also model quality as multi-attribute construct. So we borrow some of the modeling elements from these papers. But the main purpose of this paper is to analyze the feature of innovation uncertainty. innovation uncertainty has been widely observed in industries such as pharmaceutical, semiconductor, as well as battery. However, we believe it has not been fully explored in literature. So that's why we're doing this project. And that brings the connection to the second literature, which is the technology innovation under uncertainty. So when we are talking about innovation, we're actually looking at innovation happening on the product level in one single firm. So that puts us in contrast with vast literature that looks at innovation that happening to the whole industry, or process innovation, whose purpose is to reduce the marginal cost or improve the efficiency. So we differ from these work by capturing the interplay between uncertainty and technology choice when the firm determines quality provision. So that's new in this literature. Any questions? So let's move on to talk about the base model. So recall, we have a product that has two quality attributes, right? One is called the capacity, which is a decision variable for the firm. The second one is the T, is captured by T. It's called the cycle life. And depending on what technology the firm is using, if the firm uses a deterministic technology, then T will just be a fixed parameter. However, if the firm is using an uncertain technology, then T cycle life is uncertain before development, right? So specifically it could be as good as T plus delta or T minus delta, each happening half of the time, right? So we use the theta, parameter theta here to capture the volatility of cycle life. It's also a measure for level of uncertainty.
Is the cycle life could be correlated? Is it possible that these two are correlated, like the cycle life is correlated with capacity?
That's a really good question. So right now we are modeling them in a multiplicative form. It's because these two are complementary attributes. However, we assume that these two are independent attributes. Please check those. We also know there is one-to-one correspondence between the level of quality improvement and the final market demand. In particular, market demand is just a baseline market demand plus the level of improvement minus price. So let's first look at the case when the firm introduces a deterministic technology, right? If the firm uses the deterministic technology, then its objective function would just be the gross profit, which is market demand times unit profit minus fixed cost. So here, marginal cost is assumed to be linear in capacity, which is this portion of quality attribute that the firm could control, right? So cycle life does not contribute to the marginal cost, as is in the case of the battery industry. The fixed cost, on the other hand, is quadratic in terms of quality level. So it is increasingly difficult or costly to increase the quality level, and then this formulation has also been widely used in literature. So we are solving a problem that involves a two-stage decision, right? So we start from the second stage, solving for the optimal price, and then go back to stage one to solve for the optimal capacity, which directly influences the product quality. So that's how the firm should design the product quality in stage one. So let's first look at this plot on the right-hand side, right? So on the axis, let me first introduce the axis because you will see that a lot in the following slides. So the x-axis represents the marginal cost coefficient. The y-axis represents the fixed cost coefficient. We also focus our analysis on regions where optimal profit is bounded. So the color regions basically are the feasible regions. There are two observations. One observation is that, as we see in this yellow region, when marginal cost is carries sufficient weight, then it is optimal for the firm to serve just serve the existing product and offer no quality improvement. So a sufficient high marginal cost leads to no capacity improvement. Even within this blue region where it's optimal for the firm to serve the improved product, as either cost goes up, it leads to lower capacity improvement, which means the firm lowers the quality design, optimal quality design. Now let's look.
Sorry, I have a question. So what happened to the white area?
This one, this area.
Yeah.
Also, that's the area where optimal profit is unbounded.
Oh.
So because we focus our analysis on regions where there's finite profit, otherwise the firm would just offer one product that would lead to infinite profit, which is less interesting. Well, let's look at the case of uncertain technology. So if the firm goes with uncertain technology, then we see pretty much the same structure except a new scenario, right? So that's why we are putting these two plots side by side as a comparison. On the right-hand side, it shows the previous result under deterministic technology. And then on the left-hand side, it shows the optimal quality design under the uncertain technology. Let's first note when both marginal costs and fixed costs are sufficiently high, then firm should just serve the existing product, which is consistent with our previous analysis and also marked by this region with the same color. In this blue region, the firm would offer a low level of quality improvement by designing a low capacity product, right? So that's corresponding to this region, this blue region in our previous analysis, by serving the improved product, right, at any given time. However, this new green region represents a scenario where the firm would offer high capacity improvement under innovation success, but serve the existing product under innovation failure. So that means the innovation uncertainty actually gives the firm additional flexibility in how it chooses to design its product quality. And that's a new scenario, only happening under the uncertain technology. So our results are summarized in this table right here in terms of quality design. And specifically, we wondered, because we are talking about innovation uncertainty all the time. So naturally, what's the effect of innovation uncertainty, what level of uncertainty affecting this region? So recall, the theta is the measure of the level of uncertainty, right? So as theta increases, as theta goes from 0.5 to 0.75, we see this green region actually gets bigger. This means as the level of uncertainty increases, the firm is more likely to design capacity differentiated product for the market. Which means a higher level of uncertainty gives the firm more flexibility in terms of this quality differentiation strategy.
At the same time, it seems that the region where you have unbounded profit is
Yeah.
also enlarged.
That's indeed the case. Yes, but then we're only talking about the relative size. So meaning this area becomes bigger, and it's more likely for this scenario to happen, where it is feasible. So a natural follow-up question would be: now, given we already saw the result of level of uncertainty on quality design, what's the result of uncertainty in terms of overall profit under the uncertain technology? As we see from this plot, right, consistent with before, both marginal cost and fixed development costs are sufficiently high. Then the firm would offer the existing product to the market with no quality improvement. So that's when the uncertainty is irrelevant. However, if the fixed cost does not carry so much weight, then the profit increases as the volatility or level of uncertainty increases. Which means having uncertainty will be beneficial to the firm. As fixed costs start to carry more weight, then having uncertainty becomes detrimental to the firm or bad to the firm. So we try to provide intuition for this result. Specifically, when the fixed cost does not carry so much weight, right? That's when the firm set a relatively high level of capacity, right? And then this combined with a high level of cycle life under innovation success will create a really good quality product, right? This benefit, because of innovation success, is huge, so huge that it outweighs all the costs. So this is what we call the quality multiplier effect. And because the firm can leverage this effect, it can achieve huge benefit, and then eventually making the uncertain technology dominant. However, when fixed costs start to carry more weight, then the firm is forced to reduce its offering on battery capacity. So this effect is no longer true. And that's when the deterministic become dominant. So recall, in our base model, right, we look at the effect of uncertainty on the profit under uncertain technology only. However, because the deterministic problem in the base model is a special case of the uncertain problem, by setting the level of cycle life to be setting the volatility of the cycle life to be equal to 0. That means we can use the previous analysis to facilitate the result on technology comparison, especially wherever having uncertainty is good to the firm should use uncertain technology. Wherever the firm having uncertainty is bad to the firm should use deterministic technology. And here, the firm just serves the existing product, so technology comparison is irrelevant again, right? Now, as a natural follow-up, we want to do an extension to relax this previous assumption by making the deterministic problem not a special case of the uncertain problem, right? So recall before we have equal expected cycle life between these two technologies, and right now we're trying to make them unequal. So the intuition behind this is we suspect the uncertainty still affects the technology comparison, which means the previous results still hold true. But on the other hand, there will be a new result. There will be a new effect from the unequal expected cycle life. So indeed, let's look at this bottom left region, right? So we just talked about two effects that might come into play. The first effect, so here the cycle life is actually in favor of the uncertain technology, right? So uncertain technology already has one advantage, but in this region where having uncertainty is actually beneficial to the firm. So that also favors the uncertain technology. So in this lower bottom region, uncertain technology has two advantages. So that's why it's always preferred. But as the fixed costs start to carry more weight, then having uncertainty will be bad to the firm, which makes deterministic technology also having some kind of advantage. So the comparison comes down to the marginal cost. When marginal cost is relatively small, then the firm could design a really high level of capacity, making the advantage in terms of expected cycle life less pronounced. So that's when deterministic technology dominates, right? But as marginal cost increases, this advantage in terms of cycle life becomes bigger, until at one point, uncertain technology is again preferred. So we also did some we also did similar analysis, but looking at the alternative case where the deterministic technology has some advantage in terms of expected cycle life. So as you can see, when TD, which is cycle life advantage, increases, deterministic technology is also preferred in like a larger region, right? But the analysis is similar, and then the overall result is summarized by this table right here. So we conclude our presentation by offering you some of the textbooks, right? So the first thing, that we actually look at the problem of a product design of a new product introduction, and then we model it into a two-stage game, right? In the first stage, the firm solves the product design problem, and in the second stage, the firm solves the pricing problem. So we show with the quality uncertainty, the firm has more flexibility in offering capacity differentiated product to the market. And actually, when fixed cost is less important, the firm is able to leverage this quality multiplier effect and prefers to use the uncertain technology to develop the next generation product. However, when fixed costs start to carry more weight, then this effect disappears and the firms start to use the deterministic technology. We also show our main results are robust, even if expected cycle life are unequal between these two technologies. As future extensions, we could look at one thing to look at is the inter-firm competition to allow one more player in the marketplace. The other thing to look at is the inter-firm versioning. For example, now if the firm could offer multiple versions of the product from the same product line with quality uncertainty, how would this affect the overall result? So that's it. Thank you.
We have time for a few questions. So I have a quick question.
Yes.
So this work is motivated by battery
Yes.
Innovation. So and that's why you have two attributes kind of come into play and then drive all these interesting results that you derive. Are there any other examples that share, other applications that share similar characteristics or features that you see this work can be applied to?
Okay, that's a really good question. So our problem is motivated by the innovation uncertainty that we see during the product design process. So for industries, like I mentioned before, for industries such as pharmaceutical, semiconductor, or battery industries, where it involves a long period of product design and involved with huge innovation uncertainty up front, this could be applied. And also it applies to products where the quality cannot be only measured by one quality attribute. Because especially for battery product, it has multiple quality attributes, and some of them might even be uncertain of priority. So that's what we are offering to this literature by allowing this one more feature of the level of innovation uncertainty.
So as long as the product has multiple features and different quality, then this work can be generalized and be applied.
Yes.
To a wider range of applications.
Yes, and then, as you can see, this is a highly stylized model with nice results. So we think it's easily extendable.